All right. Welcome everyone to the Smart Labs Town Hall for Chemistry. This meeting is being recorded and we'll let folks know as they enter the Zoom meeting, just so everyone's aware that we are recording. We have a short presentation put together with a series of panelists today to introduce the Smart Labs program and explain how this program came to be in the Office for Sustainability and what that means for occupants of the chemistry department and researchers who are doing work in the chemistry building. And I see that Jesse just signed on. Jesse, so you're aware we are recording. Okay. When I go into presentation mode, it's possible that all of your faces will disappear. So please feel free to put things in the chat. I will see things there if you need to notify me of anything or if you have any questions, or just call out. Okay. Oh, good. Not everyone's face disappeared. That's great. So as I mentioned, your building is becoming a smart lab. That includes the older chemistry building and the chemistry addition. As many of you are aware, the older portion of chemistry just recently underwent a renovation. We're going to get into all of that and what smart labs means in the context of other projects you've seen in your space. This is hosted by the Office for Sustainability. My name's Christine. I'm in the Office for Sustainability. We'll do a little round of introductions for our panelists. Here's what you can expect to learn about today. Welcome to all of you. We're going to meet the panelists. We've got Anna Towns with the College of Arts and Sciences, Tom Smith with Free Flow, Clarissa Lynch with Environmental Health and Safety, Keith Popple in the Sustainability Office with me, and Ed DeBerry within the Chemistry Department. So once we meet our panelists, and each of them will get an opportunity to speak to their area of expertise and how they or their stakeholder group will engage with the Smart Labs program, we'll introduce you to the next steps for Smart Labs, how to prepare for the ventilation risk assessment. It's really easy. And that comes primarily in the form of an occupant survey. We'll also have moderated question and answer session at the end. But of course, please feel free, if you have questions throughout, I don't see a problem with letting us know in the chat, or just raising a hand and letting us know. So here are our panelists. You all probably have heard my name in some capacity over the last few years. I'm Christine Alencar. I manage our Sustainable Labs program in the Office for Sustainability. That includes Green Labs and Smart Labs. Green Labs is very people-focused and choice-focused, whereas Smart Labs is more centered around building retrocommissioning, making the building work as it should for the researchers in that space, and joining safety and sustainability and energy efficiency, safety and efficiency for a more sustainable lab building. Ed DeBerry, as I mentioned, is with the chemistry department. He's the infrastructure manager for chemistry in College of Arts and Sciences. Clarissa Lynch is the assistant director for research safety and chemical safety officer for the Office of Environmental Health and Safety. Keith works with me. He's an energy and sustainability engineer in the Office for Sustainability. Tom Smith will also be joining us representing Free Flow. He's the president and CEO. And we are also joined by Anna Towns, the director of space planning and management in the College of Arts and Sciences. So some of you may be wondering, what is a smart lab? What does that even mean? It is a research space that's optimized for safety and efficiency. We really want to put safety at the forefront of this initiative. It uses a combination of physical, administrative, and management techniques to assess and optimize, maintain laboratories. I want to emphasize the maintaining of lab buildings. I think that's what makes smart labs special and unique, is that once we finish this project, our office doesn't disappear. We don't go away. You're probably still going to hear from us. I hope that's a good thing. And that's because the principle of the Smart Lab program is that we're maintaining these buildings through the life of the building, and coming back and making sure that things are working as they should, in a sustainable, safe way. We're implementing targeted ventilation upgrades and LED lighting, followed by long-term change management. Things are going to change. People will move. People may retire. New hires may come in, whether they are research faculty or staff or graduate students. And with that ebb and flow of people moving and processes changing, possibly, change management is an important part of the Smart Labs program to ensure that we're tracking those changes and responding appropriately when it comes to ventilation in the space. And of course, it relies on open engagement with building occupants and researchers in coordination with other key stakeholder groups. That means you're going to hear from me frequently, or you might hear from Fiona Hogan, our Green Lab specialist, or Keith Koppel, or Ethan Heil, some of the engineers in the Office for Sustainability. But our goal is to serve the occupants in the building and, once again, create safe, efficient lab spaces. But I'm going to quote Keith here. Keith always says, it'd be really cool if we invented smart labs, but we didn't. We didn't invent smart labs. This is not unique to the University of Virginia. This is a well-iterated, reproducible approach that has been iterated at multiple institutions across the United States. It started out at UC Irvine, but it has trickled and become something of a new approach to lab sustainability and lab safety. Universities like CU Boulder, Emory University, but also national labs like Lawrence Berkeley and Los Alamos National Labs apply this approach to their lab building management plans. But again, this is about sustainability. I wanted to highlight, what we consider to be sustainable is good for people, profit, and planet. That means it's going to be good for the people in the space, and a healthier space for you, hopefully. It's going to hopefully reduce your utility bills, but it's also good for the planet. We're reducing our emissions and reducing that carbon footprint of research spaces. So it's a win-win-win. And just to further illustrate that, we're drawing on compiled resources like the Smart Labs Toolkit through the International Institute for Sustainable Laboratories. These are tools and resources that our office and team are using as we apply these strategies and as we apply this approach to the chemistry building. So again, well vetted. We're not reinventing the wheel. At this time, I'm going to turn it over to Anna Towns, and she'll talk with you a little bit about the history of the building itself and some other projects that you may become familiar with in the coming months.
Yeah, so Christine, thanks for putting this together, and team. I first wanted to say that in Arts and Sciences, we have found the Sustainability Office and now the Green Labs program group to be really fantastic partners, really, really patient with us, very much iterative, as Christine noted, in terms of working through to really understand our buildings and the needs of our research as we seek to make some improvements to save energy. So the chemistry building was finished in 1968. It was part of a kind of a Cold War era in which lots of very large research buildings were built all around the country and in fact internationally. Gilmer Hall was finished in 1962. Over the past 4 or 5 years, we have been renovating first the chemistry building and then Gilmer Hall, with a lot of planning going before that. As part of that renovation, one of our major priorities was energy savings. These buildings, when they were designed, had almost 100% one-pass air through the labs, which means 100% fresh air coming in, and very frequent air changes in the labs, which is one of the most major, most significant uses of energy in our buildings. So with the renovation, we've made some improvements, substantial improvements, but towards a point that Clarissa made, you know, a major renovation project is a project in which you bring in fantastic consultants, fantastic contractors, and work kind of in a one-time focused way at making improvements in the building. What we're seeking to do now with this next phase of the Green Labs, Smart Labs program, is to really fine tune and really, as Christine noted, be much more iterative and much more specific in terms of tuning up our labs to seek to make them A, healthier, B, safer, and C, more energy effective. We have a number of projects happening in the chemistry building, most notably over in the chemistry addition. That addition was completed, I think, in 1988, 89, something like that, early 1990s. We are replacing the exhaust system for the building overall with a new manifold exhaust system happening up in the penthouse of that building. That's going to be a complex project. We've been working on planning for it for a number of years. It's also going to be complex to implement. And Ed DeBerry is proving to be really the most important kind of contact for chemistry and the departments in the chemistry building as that project goes forward. So we will be working iteratively with you all. There will be disruption in the labs, but we're going to seek to minimize that disruption as we go through and complete that manifolding project. Out of that project, we then identified a need to replace fume hoods in the building, or perhaps we identified that in parallel. And that's a project that's still in planning. It's going to dovetail a little bit with the exhaust manifolding project, but not precisely. So that's another project where we're going to need to ask the department really to bear with us as we work through the building to replace the now 30-plus-year-old hoods and get them functioning really appropriately and as they should. As this Smart Labs program goes forward, Ed, Aaron Printy, who is also in the Dean's office as a space manager, and I are contacts if anyone in the department, anyone outside the departments has questions, or if we can assist, or if there are concerns. But I have to say, having just been working over the past months with Christine and Keith and team, again, I'm really confident in this team with Three Flows, excellent work. And I think we are all going to find it, first of all, really a very rewarding and interesting project. And second of all, a project that we can have confidence in.
Thank you, Anna. I assume that was the pause. Are we ready for Tom now? Are we ready for Tom Smith?
Okay. Hey, thank you very much. I apologize if my communications are a little bit conflicted here. I'm in an airport, but I'm Tom Smith. I'm with 3Flow, and we specialize in airflow systems for labs. We've been in business over 27 years, and our objective is really to find out the right flow and make sure that the systems are performing properly to meet the needs of the occupants. Can you next slide, please? Okay, so we recognize that, you know, the activities in labs are very critical to meet the mission of the organization, and there's lots of different activities that can be conducted within laboratories, and even within the building can have different types of labs and different types of activities with a wide range of operational requirements. And so first and foremost, we need to understand the types of activities that go on in the spaces and how those translate to the demand for ventilation and the operational requirements to promote success. And so we'll look at all the different spaces and characterize their application. We like to work very closely with the occupants and with environmental health and safety and with the facilities operations staff to make sure that we understand the application, translate that to operational requirements, and then enable the systems to operate effectively. Next slide. So one of our tools is that we're going to evaluate each space in terms of where's the risk. And labs are not one size fits all. In this diagram, you can see a floor plan. All the labs are down the center, support spaces around the edges, and then offices on the perimeter. And this is not a reflection of the chemistry building, but what it shows is that there's a tendency to think of all these labs as having a similar type of activity. But in each space, there can be a wide variety of different types of hazards, different types of procedures, and different operational requirements in terms of temperature, humidity, cleanliness, and so forth. So we want to understand where's the risk. We want to see if there's any need for special safety measures, and where is ventilation absolutely critical so that we can apply the due diligence to those spaces and make sure that they're getting the attention that's required to enable success of the occupants. Okay, next slide. So we look at the ventilation systems as an important feature for safety. In fact, fume hoods are the #1 safety devices found in labs. And so we need to make sure that they have the appropriate flow. And that means the face velocity when the sashes are open, the minimum flow when the sashes are closed. But that also translates out to the laboratory environment. As the hood goes, so does the flow through the lab. And so the air supply has to track that hood flow. And then we need to have sufficient flow through the space to dilute and remove contaminants. And that's often termed the air changes per hour. And so we need to make sure that we're programming systems correctly with the appropriate values so that we're maintaining the safety that's required, also the environmental conditions, and then keeping the balance between the labs and non-lab spaces so that there's the flow in the appropriate direction and we have the pressure cascades. So ideally, what we're going to do is identify the ventilation requirements, but we also want to look at additional safety measures. In this diagram, the simple diagram, you can see 2 people working in the center on the bench top. There may be some contaminants that need some special containment devices or exposure control devices, such as spot exhaust or a ventilated enclosure. And so we can look to see how those get integrated into the overall solution as well. So again, as has been mentioned previously, safety is our #1 objective. We want to promote occupant success. If we do that successfully, we will minimize energy consumption and make the labs more sustainable in terms of long-term environmental stewardship. So that's the slides here, and we look forward to working with everyone to gather the appropriate information. The risk assessment is about surveying the lab spaces. We look at all of the exhaust devices, the fume hoods, any other enclosures, we rate those. We then look at the larger lab environment and rate that space. It uses a 0 to 4 scale, 0 being negligible risk, no risk of inhalation hazards, to 4, which is really a special case that may need special solutions for that type of space. We will rate each space and then score it so that we get a evaluation of this risk spectrum. And then from that, we're going to derive the appropriate operating specifications. So there's no longer a need to guess. We're going to address those flow requirements specifically based on the activities and the needs of the occupants. And so that's going to give us the information that we need for fume hoods, for the lab air change rates, pressurization, and even the exhaust stack discharge requirements. Okay, I think that brings me to the end. So we're looking forward to working with everybody, and thanks again. We appreciate the opportunity to move forward with y'all.
Thanks for joining us, Tom. I'm going to turn it over to Clarissa Lynch with Environmental Health and Safety.
Thanks, Christine. So the QR code in the top right corner, that will take you to Environmental Health and Safety's main webpage. So our fundamental mission is to support research and education activities at the university so that you all can continue doing your research and teaching in a way that's going to be safe, healthy for you and the environment, and then also that we're staying compliant with regulations and with best practices. So our office has been a key partner of Smart Labs through their various projects, and we're really here to collaborate with the experts, with Tom throughout the LVRA process. We want to make sure that these ventilation management plans make sense for our users and our buildings and what the risks are. Our office and our lab safety consultants, biosafety, our industrial hygiene group, we all do regular consults and advise occupants on mitigating various risks on a as requested basis, or it could be through making observations during a regularly scheduled visit. So this is a really great opportunity to look at these lab ventilation systems, the exposure control devices, and the risks as a whole. So with a really great systematic approach. And then our office and our subject matter experts, we have, of course, a unique understanding of how all these laboratories operate and the risks that are present, because we have various touch points on an annual basis. Through visits and inspections, and again, as any requested interactions with these users. So we're just here to collaborate as needed throughout the process. And we're also an additional resource should you have any questions about the process.
Thank you, Clarissa. I'm going to turn it over to Keith Koppel in the Office for Sustainability.
Thanks, Christine. So I work for the Office for Sustainability. We are a partner as part of this team who's executing the Smart Labs program. The Office for Sustainability, if folks are not familiar with our team, we manage UVA's energy portfolio inside buildings. And we also have a large team of folks who are dedicated to outreach for staff, faculty, and students as well. So there's a number of programs our office leads. If you have any questions, you can always reach out to us or look at our website. I think it's sustainability@virginia.edu. My name is Keith again. My background is a mechanical engineer. I'm a professional engineer with many years of experience designing building systems, including critical spaces such as laboratories, clean rooms, and vivarium. UVA has recently published sustainability goals for 2030, where we have dedicated resources and have made efforts to plan to be carbon neutral by 2030 and fossil fuel free by 2050. So these are pretty aggressive goals, and a large aspect of those goals is going to be relying on establishing and implementing programs such as the Smart Labs program. So we have common goals that we want to make sure that we communicate with everyone in arts and sciences. We, as folks have said previously, safety is definitely our #1 focus for this program. So we don't want to do anything to jeopardize safety. So we typically go through, work closely with EHS. We talk with researchers to figure out what kind of chemicals are being used in the space, what type of research is happening, looking at exposure control devices and everything to make sure everything's adequate for the research that's happening, as well as looking at the building mechanical systems to see how they're functioning and if they're operating as expected. And then we also make upgrades to those systems where we see deficiencies and opportunities to increase the efficiency without negatively impacting safety. So the more that we can right size the systems in the building, the more success we'll have for safety as well as from an efficiency standpoint. As Christine mentioned previously, we didn't invent this program. We would have loved to, but the program does provide a quantitative means for us to look at each lab and decide what's the right airflow to put in that space that's appropriate for the research that's occurring. As Anna and Tom mentioned, design teams frequently don't know exactly what is going to be happening doing research within each different lab. So they make rules of thumb and assumptions and are typically conservative whenever they're sizing the airflows for buildings, just because a lot of times they don't know what's happening. I can go to the next slide. So specifically what we're doing in this building is a number of things. As folks are aware, the building has undergone a recent renovation for the original part of the building. A unique aspect is the oldest part of the building is now the newest part of the building from the way it looks to folks in the building. And our goal is to make the addition, which is actually the newer part of the building, look a little bit more like the recently renovated portion of the building. So we are going to be working with automation services within facilities management to integrate occupancy sensors into the building automation system in the chemistry addition. The chemistry portion of the building is already complete. We just need to do some programming there. So we're also going to be installing LED lighting in the chemistry addition, as well as window film in targeted areas in the building. And a big portion of what's going to happen is we're going to be applying new airflows to individual labs based on the results of the ventilation risk assessments that 3Flow is performing in partnership with environmental health and safety, as well as incorporating nighttime airflow setbacks. We understand there were some issues with how the recent renovation was incorporating nighttime setbacks that were perhaps a little bit too aggressive from a temperature standpoint. So we're trying not to replicate those issues that had been happening previously. And as Anna mentioned, there are a couple other pretty large projects that are ongoing in the building that folks in the building are probably aware of, like the exhaust manifold project that I think is kicking off pretty recently, and then the upcoming fume hood replacement projects in the addition. But again, our goal is to coordinate closely with researchers and minimize disruptions, but combine efforts as much as we can to minimize the amount of times we need to be in the labs and disrupt things. And then, when we are in the labs, we're going to work closely to protect equipment and not generate excess dust and everything like that. So we don't want to have any surprises in the labs. And our goal is to communicate as much as possible about what researchers can expect when we are in the space. I think I'm going to turn it over to Christine. Oh, no, sorry. So this is an example of a recent project that we did here at UVA. This is in MR4, where we were able to actually reduce the number of light fixtures whenever we performed a renovation, as well as increase the light quality from changing out the lights from a fluorescent fixture that was an older style fixture that didn't produce a very good quality of light to newer LED fixtures that have a better light distribution and are much more efficient. So we actually were able to maintain at least the same lighting that was there before with many fewer fixtures, and then also with a much better quality. And we received a lot of positive feedback from the researchers about those efforts in MR4. So the lights at the addition for chemistry are a little bit different, but you can kind of see an example of the kind of work that we've done in other laboratory buildings.
Thank you, Keith. I also wanted to share that we've partnered with researchers in the chemistry department before. A few years back, we put together a pilot lab program. This was really what would be the beginnings of bringing smart labs strategies to UVA. The pilot lab program really consisted of a partnership between the Office for Sustainability and 3 research teams across grounds. One of them was the Harmon Lab in the chemistry department. They are in Chem Addition, and we replaced the lights in their space, upgraded those to LEDs, and coordinated the work for that project. We also led a certification project in that lab, where they became a gold certified green lab. And what that means is they partnered up with the green lab specialist. At the time it was me. Now we have Fiona Hogan, who's on this call. She is our green lab specialist. But labs can partner with the green labs program and the green lab specialist to to have really a guided tour through our certification project process and receives that credential through our office. There's a wide variety of things that labs can do because all labs are very unique. You can pick and choose which actions make sense for your space. So in a chemistry lab where you don't have a lot of freezers, for instance, maybe you don't take on a lot of credits from the cold storage section of certification, but you're doing a lot more in things like chemicals and reagents or electronics and appliances. We also have an engagement section in our certification. So there are ways for labs to receive credit doing things like getting involved with our working group or taking DEI training through our diversity, equity, and inclusion programs here at UVA. So there's a lot of ways that labs can get recognition for being more sustainable. But I wanted to highlight this project because it was a really positive experience working with them. There were 10 active members in the lab, and this was a synthetic chemistry lab. So large glove boxes, -80 temperature probes inside those glove boxes, pretty flammable stuff. I don't know, Clarissa could probably run circles around me trying to explain the risk level in this space, but we were able to get new lights into that space and work closely with the research team to make it happen smoothly. And that's our goal for every single lab that will be involved in Smart Labs in the coming months. I have a lag on my slide advancement. I'm afraid if I keep clicking, it's gonna like jump ahead. Another quick plug for our Green Labs program. Right now, you can sign up for the Shut the Sash Challenge. And it's really easy in the chemistry department because you have sensors on your chemical fume hoods that show us where your average sash position is. So all you have to do is set a goal to improve whatever your average is. And last year, 3 labs, Mahan, Gano, and Zoo, oh, and Landers, excuse me, 4 labs saved $34,000 in a single month. And altogether, they had 56 chemical fume hoods. So that just goes to show that just 4 groups can have a pretty significant impact with a seemingly small action. So with the QR code on the page, you can register for this year's Shut the Sash Challenge. That's happening through the month of October. And stay tuned. We're always redesigning our programs, but generally speaking, we have a Shut the Sash Challenge every October. And then every spring semester, there's a freezer challenge. So lots of ways to engage with our Green Labs program. So where are we now? If you look at our little "you are here" bubble, we're at the very beginning of this journey. This is the occupant engagement survey and town hall step. Many of you probably haven't seen the survey yet, but there will be emails going out, and you will see very soon little flyers like you see here, the Smart Labs with the blue and the green. You'll see those posted around the building. You can scan that QR code to take a quick 10-minute survey on Qualtrics. The survey is an opportunity for us to get to know your lab before Free Flow's industrial hygienists are on grounds or environmental health and safety. So again, a group of industrial hygienists will be carrying out the ventilation risk assessment. That is scheduled for the week of October 24th. So almost exactly 1 month from now. So in about a month, there will be industrial hygienists in the building having scheduled meetings with a representative from your lab. But ideally, we have this survey in hand prior to that. Again, it allows us to get to know your group and your processes before we're in the space so we can move faster. Those risk assessments in person usually don't take any more than 30 minutes, anywhere from 15 to 30 minutes. In the meantime, there's going to be evaluation of the lighting and airflow controls throughout the building. So that'll be Keith's focus as Ed DeBerry and myself are preparing for the schedule of the ventilation risk assessments. After all of that takes place, we'll identify new airflows and building opportunities. We'll find things that need to be fixed or fine-tuned. Then after that, building optimization, we'll apply new airflows that will come. It'll be a while before we're applying new airflows. And then once that stage is complete, it's simply ongoing performance and change management. So are folks moving, or are any processes changing significantly where we need to rethink what the airflow is in a space? So this is really turning the dials and tweaking the system, tailoring each lab so it's meeting the needs of the researchers working inside. For this last bit, I'm going to turn it over to Ed DeBerry, who will be helping with scheduling the ventilation risk assessments with myself. So Ed, I wanted to make sure you got some face time.
So I'm your infrastructure manager. So I've worked with most of the faculty here in many of your labs. And so this is your link up for your smart labs information. I'll be working with them for scheduling where they're going to be and how they're going into labs for that week. And if you have any issues with that, feel free to give me a holler.
All right, thank you so much, Ed. And as Ed said, you can scan that QR code. There will also be flyers coming to the building soon, and you can do it from there. It should be about a 10-minute survey process. So with that, are there any questions for or among the panelists? And I'm going to stop sharing the screen. Well, I guess that's good. We must have covered everything very thoroughly. I have a question for Fiona. How much longer are you going to keep the Shut the Sash challenge link live?
Probably until the end of this week. I will make an exception for any of our chemistry labs for sure who'd like to still sign up.
Great.
Just for purposes of having this as a resource to folks who may want to check in on this town hall later, I again want to endorse this Shut the Sash and also the refrigerator freezer program. They save substantial amounts of electricity if people can just sort of learn those habits of keeping sashes down. We also, the Arts and Sciences, would like to partner with folks who would like to replace older, less energy efficient freezers or refrigerators as a priority throughout Arts and Sciences. So if you can identify equipment that might be an energy hog, please let us know and we will seek to support as we can kind of change those things out.
That's great to hear. Anyone else? Well, lucky
I was just going to
for-
say we're excited to be. Yeah, just going to say we're excited about the project and we're happy to partner with Arts and Sciences and UVA Automation, 3Flow, the maintenance zones, everybody who's going to be involved in the project. So we're excited.
Yes,
Yeah, thanks in advance for everyone's help.
thank you all for giving us your time. Thanks Keith and Ed, Clarissa, Anna, Tom, and everyone else on the call. I'm going to stop the recording now, and this will be posted to UVA's Sustainability Webinars webpage. So if you Google UVA Sustainability Webinars, you will be able to find this and a host of other online resources on our website. And thank you all again so much.
And Ed, maybe we can
Thanks,
email
everyone.
that link around to folks in chemistry so they can check in on that with as they have questions. Thanks.